Hey everybody, I was asked this question by email, and since first, math is super difficult to explain over email, and second, since this is a good question that I thought everyone would benefit from, I wanted to go through and graph this sine function here. So the problem is from the book. Those of you that are taking a look at the textbook online, you can find some extra practice problems there. The problem is from the book. It is f of x is equal to 5 sine of 5x plus 20 minus 2. So I want to go through and analyze this function, partly because the phase shift is funny and it makes it difficult to graph, and maybe this will help you out a little this weekend as well. So the first thing I do remember is factor out the b term. So I have f of x equal to 5 sine, and I have 5 times x plus 4 minus 2. I just realized you can hear my coffee pot brewing in the background, so I apologize for that, but hey, coffee is like life. So as far as bringing everything out of the equation, the first thing we have is the amplitude. So it's equal to 5, so there's our amplitude for that. And if I look at the b term, remember b is what we factored out, so b here is equal to 5 as well. B gives us our period, and the period for sine and cosine graphs are 2 pi divided by b. So 2 pi divided by 5. And then we also have a phase shift. There's my coffee, it's ready. We also have a phase shift going on, so my phase shift is what's left after I factor out the b. Remember, it goes in the opposite direction of the sine. So here I'm going 4 units left, and if we're talking about 4 units to the left, it's really like moving -4. So it's -4 units left. The midline is y is equal to -2. We've shifted 2 units down. Okay, and as far as the hash marks on our axis, that is determined by the period divided by 4. So 2 pi over 5 divided by 4. Work of fractions, flip and multiply. So 2 pi over 5 times 1/4, and simplifying that, I get pi divided by 10. All right, now before I go to graph this thing, first thing I want to talk about is the phase shift versus the period marks. So we have a phase shift that is 4 units. It's not in units of pi. And then we have to put tick marks on the graph every pi over 10. So that is hard to mark on the graph just because they're not in similar units. So what I would do in this case is put this pi over 10 in your calculator to get a decimal representation so that you get a good idea of where to put these hash marks on the graph. So if I am looking in my calculator, pi is 3.14159 forever and ever. Divide that by 10 and you get just 0.3141 blah, 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 blah. It would continue on. So about a third, or just shy of a third, I'm going to put another mark on my axis. So if I am looking at this, then I'm going to graph it over here. I'm going to move that. Woo. Okay, so if I'm looking at this, here's my x-axis. I'm moving 4 units to the left, so I'm going to actually put my y-axis way over here. Since my period marks are 0.3, it means that I'm going to have a whole period in like 1.2, which means to get up to 0, we're talking like 3.5 periods already that I've graphed on this thing. I don't need to go all the way across. So marking here, I'm going to say 1, 2, 3, 4, just to give me an idea, and I'm putting these numbers on the top, where normally my personal preference is to put them on the bottom. Those are just to give me an idea of how far left I'm going. For the midline, I'm going 2 units down. Ooh, and then I've got a 5 here, so let me extend this thing. Amplitude of 5 means that it's pretty tall. So my midline is at -2. Which is here. And I have an amplitude of 5. So 1, 2, 3, 4, and 5. All right, so I'm going to be using pretty much that entire space. As far as the 4 is concerned, so this is where I'm going to be starting my graph. So my sine graph is here. And remember, sine is the one that starts at midline, goes high, hits midline, goes low, hits midline. So this is my sine function. All right, so that is my original point. My -4, I've shifted 4 units left. Now I have to put a hash mark about 0.31 away. So if I am putting it about 0.31 away, this would be my pi over 10 from the -4. So this is like -4 plus pi over 10. If I put another mark there, little thirds, a little less than a third, let me move those a little more. So right about here, and the 4th one, there, here, these are estimates, here, and we continue on. So I'm not going to graph this whole thing, but you get the idea. Every pi over 10, I'm moving and moving 1 over. So at the second point, I'm at my high point. So I'm way up here. Third point, I'm at my midline. 4th point, I'm at my low point, way down here. 5th point, I'm back at my midline. Then I'm up high. Then I'm midline again. Then I'm down low, and so on. So this thing is really squished. Oop. And it would continue on. So again, we're moving pi over 10 units every time that we make a mark, and our phase shift is 4 in the left direction. So this is the basic graph of the thing. Very, very, very steep. So looking at it, it is very steep. Now, if I were to take a look, I'm going to shrink this down for a second and see if I can get a graph going here. All right, if I am trying to get a look at this graph, this is the graph 5 sine 5x plus 20 minus 2. If we look at it, whoo, there it is. So ours is a representation of it. But if you notice on the axis here, shifting it out, -4, we are at -2. This is our initial point here, -4, -2. Representing a pi over 10 length would be this next point here. So we're shifted up 3 units. So this is 3 above. We hit midline again at the next mark. Now I had whole numbers here, so that's what your difference is. and then shifting low, it's off the map here because we're starting at -2 and going down 5, so to -7, and then again to midline, or when we reach midline again here. So this one's pretty tricky because you have the difference between units that are measured in pi and units that are not measured in pi. As far as testing is concerned, this is way trickier than what you would see on a test. But it stretches your brain a little bit, so it is something that is good for graphing. Please let me know if you have any questions, and I will see you again soon.